Alright, we've already looked at the graph of direct variation. Now we're going to look at the graph of inverse variation. In order to do that, we're just going to manipulate the general equation of inverse variation. Let's cross multiply and say x times y equals some numbers k. So this is the equation of inverse variation. And the reason we're going to express it like this is because what this is telling us is that two numbers are being multiplied together and they're becoming some number k. So let's graph x times y equals 12. So now what this is saying is two numbers are being multiplied together and they're becoming 12. So what we're going to do is set up a table of values and say what numbers multiply together to become 12. Well, I know 1 and 12 multiply together. I know 2 and 6 multiply together to become 12. I know 3 and 4 multiply together to become 12. And now I listed 1, 2, and 3 as x values. Well, that means these could be x values as well. So 4 times what? Well, 4 times 3. 6 times 2. And 12 times 1. So these are all ordered pairs of the graph x times y equals positive 12. Now, this is only half of the picture, because in order to multiply two numbers together to get a positive number, well, that just means x and y have to be the same sign. So not only positive factors of x and y, how about negative factors of x and y? Negative 12, negative 6, negative 4, negative 3, negative 2, and negative 1. So this is a table of values that's going to help us graph the inverse variation graph x times y equals 12. So let's set up some axes and graph x times y equals 12. So here's my x and y axes, which I'll label x, y, and now I have some ordered pairs to plot. 112 is not going to fit on the graph. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That's going to be way up here. 2, 6 will fit. So x equals 2, y equals 6. There's an ordered pair. And remember, 112 is like way up there, so I'm just going to bring it down and make it look like it's going to hit that ordered pair. It just won't fit on my axes. The ordered pair 3, 4, 2, 3, 1, 2, 3, 4. That can't be 6. 1, 2, 3, 4. That's why, because it's 5. Alright, so that's the ordered pair 2, 6. The ordered pair 3, 4. I also have the ordered pair 4, 3. 3, 4, 3. That's not. I am being pretty stupid right now. There's the ordered pair 4, 3. And the ordered pair 6, 2. 1, 2, 3, 4, 5, 6, 1, 2. And now remember, the ordered pair 12, 1 is going to be, that's like right here. So here is the graph of inverse variation. It's not a straight line, so please do not make it look like a straight line. And that is half of the inverse variation graph. The other half all lies in quadrant 3, where x is negative and y is negative. So we'll do the same thing. Negative 1, negative 12 won't fit. Negative 2, negative 6 will fit. Negative 2, negative 6. 1, 2, 3, 4, 5, 6. Negative 3, negative 4. 1, 2, 3. 1, 2, 3, 4. Negative 4, negative 3. 1, 2, 3, 4. 1, 2, 3. Negative 6, negative 2. 1, 2, 3, 4, 5, 6. 1, 2. So here is the other half of inverse variation. So let's take a look at this graph. This is called a hyperbola. It is more specific. It is an inverse variation hyperbola. There are more types of hyperbolas, which you'll learn in pre-calculus, but for now, this is the only type of hyperbola which we will become familiar with, and that is the inverse variation hyperbola. Let's take a look at some characteristics of an inverse variation hyperbola. There are vertical and horizontal asymptotes. There's a vertical asymptote at x equals 0 and a horizontal asymptote at y equals 0. An asymptote, which we've learned before, is a line where the graph never crosses. So this graph will never cross y equals 0. This graph will never cross x equals 0. And the reason it will never cross x equals 0 and why it will never reach y equals 0 is because of that. There is a 0 in the denominator, therefore 0 is not in the domain and hence not in the range. So you never get 0 as an output value and you never use 0 as an input value. Let's graph another hyperbola. Let's graph x times y equals -8. So now two numbers being multiplied together become -8, which means we have x and y values are opposite signs. So let's set up a table of values, and we're just going to list x values which are factors of -8. So I'm going to start with negative x values. -1, -2, -4, -8. Those are all the factors of 8. So let's list the corresponding factors. -1 times what is -8? 8, -2 times 4, -4 times 2, and -8 times 1. That's only half of the picture. Now let's list all of the positive x factors and the negative y factors. And now we have two tables of values that we can plot the graph of x times y equals -8. X-axis, y-axis. Let's plot this table of values first. -1, 8, -1, 1, 2, 3, 4, 5, 6, 7, 8. -2, 4, 1, 2, 1, 2, 3, 4. -4, 2. And -8, 1. 1, 2, 3, 4, 5, 6, 7, 8. -8, 1. So here's half of our graph. And inverse variation graphs have point reflection, point symmetry with respect to the origin. So this ordered pair reflected through the origin will end up down there. This ordered pair reflected through the origin will end up down there, through there, and over there. Therefore, they're always in opposite quadrants because of the point reflection with the origin. Let's plot these ordered pairs. 1, 8. 1, -8, sorry. 1, 1, 2, 3, 4, 5, 6, 7, 8. 2, 4, -4. 2, 1, 2, 3, 4. 4, 2. -2. And -8. Excuse me. 8, -1. 1, 2, 3, 4, 5, 6, 7, 8. -1. Here's the other half of the graph. Inverse variation graphs are functions, and they are one-to-one functions, which means they pass the vertical line test, they pass the horizontal line test. The asymptotes in this case are the x-axis and the y-axis. Those are the asymptotes, but those are not the equations of the asymptotes. The equations of the asymptotes in this case. The x-axis is the equation y equals 0. The y-axis is the equation x equals 0.